Hi, I'm with Kevin Hopwood from Ensign-Bickford, and you told me something about Ensign-Bickford. Can you tell me how long you've been in business?
That's right. We've actually been in business almost 177 years, which is the oldest privately owned company in this country. And
That's amazing.
This is. They literally they started out in the mining business, and we still to this day have people on the board who are related to the original owners.
So from mining to aerospace.
That's right. Yeah, the aerospace is a little bit later, obviously, but it's obviously a development of the pyrotechnics and ordnance stuff that we do, which is a very niche industry. So.
And it's quite an evolution.
Mm-hmm.
Can you show us some of the things that we're looking at here?
Yes, I certainly can. In this cabinet here, most of these components here, and they've just been put together just to show as a sort of a demonstration how they would connect together. But everything on a space vehicle that needs to make it either initiate the rocket motor or start an ordnance event, do stage separation. This is actually a frangible joint assembly in here, which is a way of just fracturing two metal plates to be able to separate the stages. There are other ways of doing that as well. You can use a linear shaped charge or a mild detonating cord.
So would that separate the stages of a rocket?
That's correct, yeah. That's an actually explosive charge inside a tube. And as the explosive goes off, it causes a shock event, which turns an oval tube into a round tube. And by doing that, it pressurizes and pushes on this extrusion here, which actually fractures. So enables the two separate parts to come apart. What it also does, it completely confines all the explosive inside, so you don't get any dust or soot or products of combustion, we call them. So all these components in here are all explosive components. So we are using components, the explosives, very subtly to be able to do to work. So if you look here, this is our smart initiation system. This is actually originally designed for a tactical weapon. But we've developed it for space use now, and we have it on a couple of different platforms now.
What type of platforms do you have it on?
This is actually going to be used on a capsule, a manned flight capsule. So we're just developing that at the moment with a customer. I can't tell you who that is at the moment, obviously.
Okay.
But what we've done here is we've tried to show here that we have a detonating device at the end here, and it goes through a manifold, and then we have time delay devices. One thing about explosives, they happen very, very quickly. This is happening at very, very high supersonic speed. Sometimes we need to slow that event down. So we have a burning device inside here which will slow down for, say, 90 milliseconds or 2.5 seconds, depending what sort of event you want to occur. This device here is actually a safety device. We can actually put a mechanical barrier in the way. So should there be an inadvertent firing of the ordnance device, we can actually stop it. So a lot of the range safety people actually mandate we have a safety device in there. So,
have you ever had to use that?
Not me personally, but these devices tend to be on the ground, and what happens is you then rotate them just prior to launch, so that it keeps people around the launch site as safe as possible.
Now that's very exciting. So if this were to fail or something were to go horribly wrong, what happens next?
Okay, assuming the flight vehicle is it's doing its thing, it's heading down the range, and suddenly something goes horribly wrong, and so it starts diverting off the range. There will be a system on the vehicle which is completely independent of the mission system called the flight termination system, and we have a representation here in the cabinet.
Great.
The flight termination system literally cuts down the vehicle right there and then. The range safety officer on the ground will press a button, send a signal to the vehicle, completely independent of anybody who actually owns the vehicle. And here is actually a safe and arm device. It takes a signal from the command to struct receiver. This has a detonator inside it, and it'll function, and then everything after that is automatic. It's all done with detonating transfer. And we have 3 demonstration devices shown in the cabinet here. This is a linear shaped charge, which is a chevron-shaped explosive, which focuses a cutting charge down onto a surface and will cut a hole the size of a dinner plate in, say, a motor dome, and that'll allow the motor dome to vent. And as it vents, then it dumps the pressure inside, and then the nozzle becomes non-propulsive. And the other way of doing that is on a liquid vehicle, where we have this device here, which is a bidirectional destruct charge, and it actually throws a lead plate in 2 directions and will take out the tanks. So it'll take out an oxidizer and a fuel tank, and that's used on many of the liquid-fired rockets you have around here as well.
Have you ever had to call this device into action?
Once in a while they get used. Yeah, it doesn't happen very often, but if you look on the news once in a while, say once every 10 years or so, a vehicle will actually will actually have to use it. But it's a testament to the industry here, really. We have a very, very high safety rate. We are mandated to put this on a vehicle. However, the chances of actually using it is very, very low. So which is a good thing.
Well, Kevin, that's all very exciting, and I want to thank you so much.
Dan, my pleasure.
Thank you.